So good evening. So now discuss about formation of PN junction diode. The junction diode is formed by placing a P-type crystal in contact with a N-type crystal and subjecting to high pressure so that it becomes a single piece. The assembly so obtain the called the PN junction or a junction diode or a crystal diode. The surface of contact of P and N type crystals is called junction. A PN junction diode is shown in figure. The P type region has a positive holes, the majority charge carriers. And similarly, the N type region has a negative electron as majority charge carriers. So in addition to these majority charge carriers, there are a few minority charge carriers in each region. So the P region contains a few electrons while the N region contains a few holes. So thus we find that the junction there is a decreasing a hole concentration from left to right, so which makes the holes diffuse from P side to N side. Similarly, electrons diffuse from right to left across the junction, so holes leaving and electrons entering the P side make it a negative. Similarly, holes entering and electrons leaving N region make it positive. Thus, there is a net negative charge on the P side of the junction and a net positive charge of the N side. This produces an electric field across the junction as if phased battery is connected with the positive terminal to N and negative terminal to PP section. So equilibrium is established when the field becomes large enough to stop further diffusion of the majority charge carriers. The field, however, helps the minority charge to move across the junction. The regions So the regions on the either side of the junction which becomes depleted, that means free of the mobile charge carriers, is called the depletion region. The thickness of the region is order to 10⁻⁻⁶ meter. The potential difference across the depletion region is called a potential barrier. On formation of p-n junction, electrons from n layer and holes p layer diffuse towards the junction. Recombination takes place at the junction. So and levels the immobile positive donor ions and n side and negative acceptor ions at p side. And the potential barrier developed at the junction whose voltage is a 0.3 voltage for germanium and 0.7 voltage for silicon. Then the further diffusion stops and the result depletion region at the junction. And depletion region, since the region of the junction is depleted of mobile charge, is called a depletion region, or the space charge region, the transition region. And thickness of the region of the order of 0.5 micrometers. And this junction reverse biased and forward biased. And forward bias, when a battery is connected to the diode with the P sections connected to the positive pole and N section to the negative pole, and junction diode is to be the forward bias. So if the forward bias is greater than the potential barrier, the majority carriers move towards the junction and cross it. The current which flow due to the majority carriers is called a forward current. It increases with the forward bias. And reverse bias, when battery is connected to junction diode with a P section connected to the negative pole and the N section connected to the positive pole. The junction is said to be the reverse biased. When the reverse bias is applied, the majority carriers do not cross the junction. However, a very little amount of current flows. So due to the motion of minority carriers, this current is called as the reverse current, and current increases with the increasing temperature. Thus, we see that the junction diode offers low resistance for the current to flow in one direction under a forward bias, but a very high resistance in the opposite direction, so under the reverse bias. The third act is the rectifier. And the properties of junctions. The junction contains immobile ions, that is the region is depleted of mobile charges. The region is called the depletion region. The space charge region is or transition region. In order of the 1 micron width, in the cutoff voltage is 0.3 voltage for germanium and 0.6 for silicon. And reverse saturation current doubles for every 10 degrees Celsius rise in the temperature. Forward resistance in the order ohms. The reverse resistance in the order mega ohms. The transition region increases with the reverse bias. The region is also called as the variable capacitor and known as the transition capacitance. And this is a circuit and symbol of a PN diode. The arrow head indicates the direction of conventional current flow. I already discussed forward biasing and reverse biasing, and this is a forward bias. And if it's a behaves a low resistor and current mainly due to the flow of majority carriers across junctions, potential barrier and the depletion layer is reduced. Thank you. We will discuss in next session.